Okay, so we are at number 5 now, and we need to graph this function, so we always start with the inflection point. So looking inside the parentheses here, if we have a positive 2 on the inside, we are shifting to the, let me change my color of my pen, we are going to be shifting left 2 units, and if we have a positive 1 on the outside here, so outside the parentheses, we're going to be shifting up 1 unit. So from the origin, which is here, we're going left 2 and up 1. So I'm going to plot that point. Looks like it's about right there. Let's do this in pink. So I've plotted my point, and based off this point here, my inflection point's at -2 and 1. Okay, now let's find the other 2 points. So remember, we can look at our slope to help us find that. But here's the thing, it needs to be 1 unit away from the vertex to make it as accurate as possible. So what do? Well, we take this value here, -2/3. So what is -2/3? So if I put that in my calculator, -2/3, that's going to give me -0.666, right? So I'm just going to write -66, and you can even round it. So let's round this to -0.67, so that way it doesn't continue on forever. So looking at this, remember, if we have this number, we can always put it over 1. So I'm going to put that over 1. So that's telling me I need to go down, because it's negative, down 0.6 and over 1. So on this graph here, I go to my vertex, not my vertex, my inflection point, and I'm going to go down about 0.67, so that's about like 2/3, right? Down about 2/3, but then over 1, which is right here, and plot. That's about right there. And then if I want to do the opposite direction, that means I have to go up from the inflection point 2/3 and then over 1. So that's like up 0.67 and then over 1. So that's about right here. And then connect my dots, so it looks like it's going up first and then down. All right, so I got my graph because I have my 3 points. And now I'm going to find my y-intercept. So remember, y-intercept, your x value is always 0, so x equals 0. I'm going to plug in my 0 for x in this equation. So setting that up, that's going to look like -2/3, 0 plus 2 cubed plus 1. And so, remember, PEMDAS, we're working inside the parentheses first. So 0 plus 2 is going to give me 2 cubed. I have a -2/3 on the outside, plus 1. 2 to the 3rd power is 8, if you calculate that. So I have -2/3 times 8 plus 1. If I multiply -2/3 times 8, remember I can always put a number over 1. So -2 times 8 is going to give me -16. 3 times 1 gives me 3 plus 1. Now, in my calculator, I'm going to figure out what that gives me here. Let me kind of scrunch this up and set this to the side here. Yeah, there we go. So that way we can kind of see these numbers. So -16 divided by 3 gives me about -5.33, and then I'm going to add 1 to that. So that's -4.33. Okay. So it looks like my y value, when y when x is 0, y is negative 4.33. So I'm going to put that decimal value here. So negative 4.33. And so I have my y-intercept. Now for domain and range, remember domain and range for all cubic functions are all real numbers. And if you're confused why that's the case, please watch problem 1 for more details on domain and range for cubic functions. And that's basically it.